Welcome back, everybody. Our next speaker is Jonathan Gold. He's one of our senior cloud native engineers at Container Solutions, so he's actually a colleague of mine. Jonathan, it's very early for you, isn't it?
Yep, 7:40,
7:40. Well, good morning to you. And
good morning.
You can kick us off with your talk about building a unified control plane.
Cool. Well, that's exciting. So as Charlotte mentioned, we work together at Container Solutions, helping out our customers do cloud native transformations, build internal development platforms, and fix their processes. And we spend a lot of time sort of helping streamline processes with cloud native principles. So today, as Charlotte mentioned, I'm going to talk about building a unified control plane so that you can manage everything from the Kubernetes API. If you want to argue with me as to whether or not that's a good idea, please come see us at our booth afterwards. But we're going to take it for granted that it's a good idea, and we're just going to move forward. So the first question that we have to ask ourselves is, what is a cloud? Because everybody wants a cloud, right? Oh, I want to build a cloud. I want to make, I want my own AWS or whatever. So what is a cloud? Well, first of all, it's not just someone else's computer. Otherwise, that wouldn't be a hackneyed joke, right? But in order to build a cloud, you definitely do need infrastructure, right? You can't have a cloud without infrastructure. That infrastructure could be on premises, but it could also be infrastructure provided by other cloud providers like AWS, Azure, etc. But a cloud is also APIs. You need a way to interact with your infrastructure. If you're constantly just logging into, bare metal machines and running shell commands, that's definitely not a cloud, right? But a cloud is also a platform. Now, what is a platform? That's a really good question. And if you ask 10 different people, you'll probably get 11 different answers as to what exactly a platform is. As far as I'm concerned, a platform is an experience. It's the thing that is wrapped around your cloud or your infrastructure to provide a sort of unified experience to your developers so that they go to one place and can provision whatever they need for whatever they want. So enter the unified control plane. What is a unified control plane? Is it Kubernetes? Yes. But what am I talking about? That's not enough info. Well, if the astute among you might already be thinking of one way to control things from Kubernetes control plane, which is operators. And that's a great start. There's lots of operators out there already built. You can check out Operator Hub. For orchestrating cloud resources, there's the AWS service operator, which allows you to spin up arbitrary AWS resources from the Kubernetes API using YAML. Then there's the GCP config connector, which is a little bit more complicated. And to be honest, I wouldn't touch it with a 10-foot pole because it creates its own service catalog in your Kubernetes cluster, and then you have to interact with that. So it's not as cloud native in my feeling, but there's also Kubernetes operators for bare metal, like Metal Cubed, virtualization, like KubeVirt, databases like the Postgres operator or Percona. And all of these are available to pretty much spin up on your cluster out of the box and control resources in the cloud or on premises. There are also lots of ways to build your own operators. So the official operator SDK is written in Go. And if that's your language of choice, then it's a really nice way to satisfy the operator pattern with whatever infrastructure or applications that you want to orchestrate. But Container Solutions has also worked on 2 other operator SDKs in various states of maturity. So we have the Java Operator SDK that we wrote at a customer who was a Java-only shop, and they wanted to manage their own operators. So before we started implementing operators from scratch in Java, we decided to create the Java Operator SDK and so that we could reproduce the operator pattern in a similar way that you would with the Go framework. And then recently, my colleague Sebastian Gomez at Container Solutions, who's a .NET developer, created the .NET Operator SDK. So if Java or C# are your languages of choice, definitely check out these GitHub repos, and you can start coding your own operators right away. So the operator approach has been around for a while. It's a very, very effective way to extend the Kubernetes API to control what you want to control. That's awesome, but it needs more unification. So if I want to deploy something to AWS, say an RDS database, that's going to be very different to the patterns that I use to deploy a similar resource, a Cloud SQL to GCP, for example. So how do we take all of these operators and unify them into a single sort of API? Enter Crossplane. So if you haven't heard of Crossplane before, it's a project that was started by Upbound. And the main goal of this project is to create a sort of abstraction layer that sits in front of your cloud APIs and allows you to talk to them in a similar way or even in the same way in a lot of cases. So, but diving in, Crossplane is a very large and complex project, so I'm going to try to distill sort of the killer features before we start looking at how it works. So it's an operator of operators. So it comes with controllers and CRDs for AWS, Google, Azure, Alibaba, Helm if you want to use it on a local cluster, and then a number of other cloud providers. But you can also bring your own operators. So if you're using, say, the Postgres operator to deploy a database locally on your local cluster, you can incorporate that into Crossplane using composite resources, which we'll get into in a moment. It also allows you to write custom APIs. So the operators, especially the off-the-shelf operators, have specific Kubernetes APIs that you have to satisfy. But sometimes as a platform developer, you don't want your customers to have access to all of that. For example, I have a customer who requires that all of their data stays in Canada due to data sovereignty. So in order to do that, we can hard code the AWS region, for example, into our configuration, and it's not exposed through the API. Whereas if you were using the AWS service operator, or if you were using Terraform, it's very difficult to restrict things like that. And the absolute killer app, as far as I'm concerned, is that you can use the same YAML to deploy similar resources in multiple environments. So I can use the same YAML to deploy a database, a managed database in AWS, GCP, Azure, etc., or even on premises. So how does it work? Fair warning, this diagram that's about to come up gets a little bit complicated, but we're going to dive into an example afterwards that should make it all clear. So if you have questions, please do post them in the chat, but maybe hold your questions until after the demo. So the first step to working with Crossplane is creating a composite resource definition. So this will be known sometimes as an XRD because CRD was already taken. So a composite resource definition basically a composite resource definition defines the API that you want to present to your users, right? Once you create that composite resource definition, your cluster will create two CRDs as a result. So these custom resource definitions that get created, one of them is a composite resource, and the composite resource represents the actual infrastructure. And then the other one is a composite resource claim. Now you can think of this sort of like the way that persistent volumes and persistent volume claims work. So the composite resource is like the persistent volume. It defines how the backend will satisfy the claim, and then the composite resource claim actually is what the developer uses to ask for that infrastructure. So then what happens? I'm sorry. So let's just focus in on these MySQL instances down here. This is what your developer will actually ask for. Okay, so we'll look at some code that does this, but it's as simple as you want it to be or as flexible as you want it to be. So once your developer asks for your composite resource, in this case, a MySQL instance, the cluster, the operator will actually create the composite resource from that, right? Just like your storage provisioner creates the PV from the PVC. So once that gets created, it checks some metadata and which informs the operator which environment it's going to deploy to. And depending on which environment you want to deploy to, that will invoke a composition. So a composition is a combination of Kubernetes resources, in this case, the CRDs that control AWS resources or Azure resources. And depending on that environment tag, it'll spin up a different set of resources from the same API. So this MySQL instance is basically like an abstraction layer that sits in front of RDS and Azure MySQL to translate your API calls into API calls that get what you want them to do. Now, you'll also notice it's not just an RDS instance that we're spinning up in this case. It's also a subnet group to make that connection available. So you can package your business logic into these compositions, and developers don't have to think about all the underlying requirements for those resources that they want. They just say, I want a MySQL server, and the operator handles all of the complication of it. So you've defined and offered your infrastructure. Your developers have consumed their infrastructure, and then you get to consume pizza. If this seems like a total non sequitur, I'd invite you to check out, there's a great blog post on the Crossplane website about developing your own operator, and they use pizza ordering API as an example, and you can actually order pizza off of Kubernetes, which I think is fun. Cool. Oh, that slide wasn't supposed to be there. So before we dive into the demo, I really want to invite you to the Container Solutions booth, which you can join on Brello. You can find out all about our company, but you can also ask us questions about cloud native and SRE, and we won't even charge you for the answers. You can meet engineers, engineering managers, our CTO, and our co-founders. And there's a raffle, which you can win a t-shirt, which would be awesome. Cool. So I'm going to stop sharing my slides. Stop sharing my slide. Oh, okay. And now I'm going to share my terminal. And hopefully you can all see that. Is there a way that I can find out if you can see it? That would be helpful. Anyway, I'll assume if Charlotte doesn't dive in and tell me that no one can see it, that you can all see it.
You can see it, all good.
Thank you, Charlotte. Okay, so here in this folder, I have my demo files. So the first thing that we are going to look at is the composite resource definition. So this is the place where we define the API that we want to use, right? So let's just take a quick look at that. So you can see that we are creating a composite resource definition. We give it a name. Here is where you would put your company name. And it lives in the group database. And we're naming it a composite PostgreSQL instance. So in this case, we've pivoted to Postgres, and we're going to do GCP and AWS instead of Azure. But all of the rest is the same. So we define the name of the composite resource, but also the name of the claim. We'll talk about the secret keys afterwards, but this actually gets automatically put into a Kubernetes secret, and then you can access that from a pod. So then here we just have an open API schema where we describe exactly what configuration we want to allow the users to do. In this case, all we want is storage size. We're not going to let them choose a region. We're not going to let them choose an instance size, anything like that. We just want to say, how many gigabytes of storage do you need? Keep it simple. So then, how do we satisfy that composite resource definition? We use composition. So let's take a quick look at the AWS composition. And here, so there's a bunch of metadata, etc. There's a connection secret, which we're going to write to a resource, to a secret in this namespace. We're going to create a composite resource to satisfy the composite resource definition. And that includes a list of resources. And this list of resources is just other arbitrary Kubernetes resources. So this is where you can bring in your own operators if that's something that you want to do, or you can reuse the cross-plane operators and CRDs, which is what I'm doing here. So this RDS instance, is provided by the cross-plane AWS provider. So for the provider, I'm configuring hard coding the region, the instance class, even the master username, Postgres version, etc. But I am taking this storage gigabytes and I'm applying that to spec for provider allocated storage. So that's how you take something from your composite resource claim and apply it to the composite resource itself. Okay, so if we wanted to do region, we would also do that here under patches. Then we extract the connection details and inject them into the secret. So that's the composition. And if we take a quick look at the GCP composition, you'll see that here we're just doing a Cloud SQL instance, and that's it for this one. And we have the same spec parameter storage GB gets applied to the correct path for the resource. So we have those compositions and XRDs. That's something that as a platform developer, you do once. Everything else that we're going to look at is something that your developers will do. Actually, there's the provider, but the provider is very simple. So let's just take a quick look at that. So provider just tells you which secret to use to access Google. So I've loaded my secret key and my secret key and ID and into this secret GCP cred, so it knows how to connect to GCP. And same thing for AWS. So let's look at how a developer would actually ask for this Postgres database. Whoops. Okay, so we have two PostgreSQL instance claims here. You can see the name is different. This is because I had to bake these before my talk, because the AWS one takes about 10 minutes to spin up. Otherwise, the name could be the same. The only other difference, and that's the same for the secret, but the only other difference is this match labels. So you add a label that tells Crossplane which provider you want to use to satisfy your composite resource. So you can also see if you have some configuration that is required by one of your compositions, but not the other ones, you can do that in your metadata, right? So as a label. So in this case, we're telling the AWS composition that we want to deploy in the default VPC. But anything that is common to all of your compositions will be under parameters. So in this case, storage GB is 20. So that's all a developer has to do to create the database. And then to use the database, all they have to do is access the secret. So in this case, we are creating a database that just prints the connection info from Postgres. And then we apply the secrets to our pod, as you normally would in Kubernetes. So look for the endpoint key in the AWS DBCon secret, and that tells you what to make PG host. Right? So let's take a look at how those work. So I have these two pods. They're crash looping because they just crash after they print the connection info. But hopefully the logs are still there. There you go. So the AWS test pod says you're connected to database Postgres as user master user on this host on AWS at port 5432 through SSL. So that works successfully. And if we do the same thing with the GCP pod, we see that we're connected to a Google IP. So that's how simple it can actually be for developers to deploy their applications. Once you think about how you want to satisfy their requirements, you only have to do that once. You don't create processes that explain to them how to provision RDS. Your cluster does it for you. And I think that that's a super powerful pattern that really can simplify the lives of your developers. So with that said, I'll once again invite you to check out our booth or to contact me if you have any additional questions. But I think, if I'm not mistaken, I have a few minutes to take questions now.
Yes, exactly. Thank you, Jonathan. It was an interesting talk. How many pizzas did you order?
Oh, personally, none. Yeah, I looked for other APIs to play with. The provider framework is really interesting, though, and allows you to, so if you want to create a provider for, OpenShift or for your own custom platform, you can do that as well. And it's very similar to the Go operator SDK.
Okay. One of the first questions from the chat is, how does the operator SDK compare to KubeBuilder?
That's a good question that I would invite you to come to our booth and ask someone else, because I don't have a lot of experience with KubeBuilder.
Yeah, that's perfectly fine. We do have another question.
Mm-hmm.
What use case? Sorry, Domi, do you want to ask?
Oh no, sorry. I just want to double check. Like, if anybody is still watching and is and asks questions, please drop them in the chat now. We have a little bit of a delay, but yeah. So we'll ask one more question that we found somewhere, but hopefully some other people will drop in as well. I also wanted to say thank you for the talk. It was really good. And what use cases are there where you wouldn't want to use a unified control plane?
That's a very good question. So I believe that a good platform provides users with choice. So depending on who your users are and how much control you want to give them over your infrastructure, there are reasons to maybe provide this unified control plane, but also provide other points of integration, whether it's REST APIs, the cloud SDKs. For example, software developers who are coding directly against one of the clouds, they're not going to want to re-architect their applications to talk to the Kubernetes API, even though it may be a good idea because they might want to move the application at some point. There are situations where this can complicate things, and I think if you're thinking of your users as customers, as people you want to provide with a specific experience, Crossplane is a great way to do that. If your customers are more technical, or maybe you operate on a DevOps model and the people who use the infrastructure are the same people who provision it, I would suggest providing them with Crossplane as a way to do that. But a lot of people are not, for lack of a better, a lot of people don't want to learn a new thing to do something that they can already do, right? So if I can provision databases with Terraform, I'm going to want to continue doing that. I might argue with that person that it's better to do it this way and use Kubernetes to manage the lifecycle, but ultimately delivering software is about doing things efficiently, and this may not always be the most efficient way. If you're going to have 1,000 people asking for databases, I would urge you to consider Crossplane.
Gotcha.
Thanks.
And now we have one last question. I think we still have 1 minute. How do you manage observability and security with operators?
That's a great question. So there are, first of all, I think the first step is ensuring that you have monitoring and logging set up that is cloud native. So if you're running the Prometheus operator in your cluster, it'll pick up all of the other resources that you need. There's also tools for tracing like Jaeger. So I think the answer is you take a cloud native approach to observability and monitoring. You can also, use the cloud's services. So whether it's CloudTrail or I can't remember the name of the other one. You can integrate with those, but I think, we're talking about a unified platform. You want to bring everything in to your cloud native monitoring stack. So ultimately you should be able to see everything in Grafana and get alerts through Alert Manager or PagerDuty or whatever it is that you're using. Just like it's important to unify your APIs, it's also possibly even more important to unify your monitoring, alerting, and observability.
Yeah, excellent. Hey, I think that's out for our time. I think there might have been a few more questions. So if you want, and if you're staying with us, which I hope you will, could you drop into the chat on the track? So I think some other people might have some more questions for you. As I said, thank you again for getting up early for us. And and I think with that is time for our next segment.
Okay, thank you so much.